Yeah, welcome again to my accounting videos, knowledge sharing platform. If there are people who are struggling with this kind of questions, this is the reason I'm making these videos. Let's get it started. So this question says, Mary's account has $35,000 balance. She has decided to save $250 at the end of each month and receive 4.5% per year, compounded monthly. If she continues for 9 years, how much will her account balance be after 9 years? So these kind of questions, if you are struggling with them, let me know under the post and we'll work together to solve any kinds of questions that has this nature. So let's get it started. So at the beginning it says $35,000 is the balance. So let's look at this part as compound interest part, because if this amount is in her account now, as time goes, will not be the same after 9 years if that amount is left in her account for 9 years. That part is a compound interest part. This part of which you will be putting $250 at the end of each month is what we'll call annuity. When you have the same amount put in an account at equal interval, this forms an annuity. And we have different type of annuities. So this one whereby someone puts some money in the account at the end of each month is what we call ordinary annuity. And this one here is future, because that amount she's putting money at the end of each month, and she will have a certain amount after 9 years. So this one is what we call future value, because she will have a certain amount after a certain times given. This part will work it out using the formula, and I'll show you how you can use annuity formula, and for this case, future value of ordinary annuity. So let's get started. What is the formula for compound interest? We start with the compound interest part. So compound interest, we will have amount. So that amount, and we have principal. Amount you have at the beginning now is what we call principal. And we will denote that as P. And this one, which is 100%, I'll not explain this one because of the time factor, but we will learn as we go forward. So we have 1 plus what plus R, which is the time, the rate given, which is, and this is per year. So this one is 4.5 over 1200. Let's put it that way, because this one is compounded monthly. So there are 12 months in a year. And this 100 here, the one I put at the back of it, is 100%, because this one here we have it 4.5%. So if we convert this one into decimal, we will have this 4.5 divided by 100%. So we will have that. And because of the space, I'll not be putting everything there, but I'll explain it for you to know what we're doing. So this one, we're converting this one into decimal, and that's why we have this 00, just to convert that into decimal. So we put that in bracket like that, and then raised to what? Raised to the power. And this power is the number of periods that we will use here. And how are we going to get that? This is going to be n. And how we're getting n? So it's going to be 12, which is this monthly, 12 months in a year times the duration the money will be sitting in the account, which is 9 times 12. What is it? It's going to be 108. So that one will give you 108. So this is compound interest part of it. And we are going to do what? We are going to plus this to the annuity part of it, because we are going to calculate how much will come from the annuity portion of this problem. So, and the formula for the future value of ordinary annuity is, we say F for future, V is the value of ordinary annuity. Let's say equals. What are we going to do in this case? It's going to be the regular payment, how much she's putting each month. So it's going to be 250, which is the payment each month, times 1 plus, it's like the one we're doing here, 1 plus 4.5 over 1200. And I already explained where we got this. So this is the same thing, but this one you're going to have, put it in bracket like that, raised to the same power, because it's the same duration that the money, she will be putting the money into that account. So that 1.8. But remember, this is future value of ordinary annuity. So we're going to minus 1. And then this one, you divide this part. Don't include this part to it. You divide this part by 4.5 over 1200. This one. So this is what we will have on this part. So looking at this, now we are going to calculate this part plus what we'll get from this part. And then we will see how much she will have in her account after 9 years. So let's do the calculation by using calculator. Okay, this is the calculator. I'm going to use this, but you can use either your phone or your calculator if you have calculator to solve this, and we will see what we will get. So this amount, which we said before, is the principal amount, $35,000. So you say $35,000. Okay, and then let's work out this part. So we said this one here, make sure you put a bracket, 1 plus 4.5 divided by 1200, and then put this close bracket there, and then raised to the power of 108, and then you will get 1.498167, and then more digits there. So this part here is what we call compound interest factor. This is compound interest factor, this part. So what we will do here is to multiply what you have got from the compound interest factor by initial amount, which is principal, times $35,000. So you will have on this side, you will get is going to be 52,085.85. So this part is what you, after calculating this part, what you got from the calculation there is what you multiply by 35 to get this amount. Now, you're going to do it for the other part too and make sure you add them up together. So let's go to the other part, which is this part. We got 250, but leave this one for now. Just work out this one first and then subtract 1 from there, divide by what you will have here. And then after that, you multiply this part, the whole of this part, by 250. And that's what you will add to this to get how much. So do this. You start with the bracket first, and then 1 plus 4.5. Divide that by 1200, which is this. Make sure you got that one and divide that by 1200. And then close that bracket and then raise to the power of 108. 108, which is that power. And then equals. What you got here is 1.498167,236. And that, what you got from here is the same as what you calculated from here. And let me put it down in case you get confused of what we have here. It's going to be 1.498, then 167, then 236. So this is what you have by calculating this part times the principal amount, which is $35,000. So that one, after getting this part, which is this, minus 1. Yep, minus 1. And then what you got from there, which is going to be like this, but minus 1 is going to give you 0 point this number. That's what you will have here after you subtract 1 from the figure here, which is like this figure. Take away 1, so you got 0.498167236. That's what you have after subtracting 1 from there. And divide that number by this. And when you divide that, you say divide that, put division on the calculator or on your phone calculator if you're using that. And then put bracket there. Put bracket there and then put the number is 1.5. So if you have, let me put it down in case you get confused. It's going to be 250, which is that, times, after you calculate this part, it's going to be like this. But when you subtract 1 from here, it's going to be 0.498 236. So that's what you have after you subtract 1. But you have this under is 4.5 over 1200. So you have this. So what you will do, you divide this number by this number before you multiply by this. So you say divide that, and then when you do this, you make sure get 4.5 over 1200. So once you have this, this is what we put here. When you put it in a calculator, make sure it is like this. You say 4.5 divided by 1200. So you get, this is 250 times, this is 132.8445.962. So what you have here, this part is what we'll call future value interest factor of an ordinary annuity. You got this part left, which is going to be 250 times what you got here, times 250, which is this one. So what you have here is going to be 33,211.149 and then 04. Okay, so this is $33,211 and that part. So what we're going to do from there, you can round this one up to 5. This is going to be two decimal places. So you take this one round there. So you're going to have 33,211.15. Okay, now you have this amount, which is from the annuity part, and you have this amount, which is from the compound interest part. Now you're going to add them up together, this one plus this. So if we have that, it's going to be 33,211.15. So add them up together like this, and that will give you what? Add them up together. This is going to give you 0, and then 1 up because that was 10. So you have 9, 10, another 0 point, and you're carrying 1 from here because that was 10. You got that 6, 7. So 7 there. 3 plus 1 is going to be 4, and then 4 plus 2 is going to give you 6, and you got 2 plus 3 is going to give you 5, and then you got 5 plus 3, it's got 8. So, and this is a $sign, so you have this amount. So this is what she will have in her account after 9 years. So this is the answer. If there is something that is not clear from this video, please let me know. That's all for this video. If you have found this video helpful, please like it, share it with others, and also make comments where I will make improvement if there's something that you would like me to improve on. Thank you so much. See you next time.